All right, so it is, where's my pen? There it is. It is the 10th, 3, 10, 22. So today's objective is we're going to be dividing polynomials by binomials.
Goodbye, sir, Mr.
Yeah. Are you going?
Yeah, I gotta go to my taxi.
Okay, watch the film tonight, okay?
Will do.
There you go. So, polynomials by binomials. But the first thing we're going to do, and we're going to do it by long division.
Yay.
It is hard. You're not going to like it, I'll be honest, but we're going to do it together. We're going to do it slowly, okay? So I like to start an example with just a plain old number. We're going to go back to 5th grade math for just a little bit because the process here is the same as the process here. X's are just numbers that we don't know, okay? X's are just numbers that we don't know, so the process of dividing regular whole numbers will be the same process of dividing polynomials. So let's start. Number 1, I would do this 5 divided into 431, right? And we know what we're going to do. 5 does not go into 4, but 5 goes into 43. It goes into 43 8 times, so I put an 8 here. Now what we do in our head is we really do this. We really go 8 times 5, don't we?
Yeah.
Okay, so we really go 8 times 5, which is 40. And it's a positive 40, correct? But we subtract that 40, and 43 minus 40 gives me a 3. All right. Then, what we're going to do is bring down the next term, right? Slow down for a second. So then if I bring down the next term,
Wait, are you subtracting for me or?
I went 43 minus a positive 40, right? Which I'm basically subtracting, yes. Now I did this on purpose. You're going to see why I did this on purpose, okay? Bring down the next term, so I bring down the 1 all the way down. And then I'll divide again. Now this time the 5 is divided into the 30, right? And we know that goes in 6 times, so I put the 6 right above the 1. Okay, I know I'm showing you stuff you already know, but this method is going to be helpful for this, right? So 5 goes into 30 6 times, and we know it's 30, but what we really do is, in a sense, in our head, we take 6 times 5, which makes 30, and that's a positive 30, but we subtract, right? And then we get 1. Now at this point, we could add a decimal point. And we can bring down to 0, correct? But we're not going to do that. We're going to keep it as a fraction. So, yeah, Lucy?
Can I get water real quick?
Sure. So my answer is going to be 86 and 1/5. So you agree with that? Because the 1 is my remainder. And so since we're dividing by 5, we've got 1 out of 5 left over. Okay? Thumbs up? That's pretty easy, right? Now, the exact same process will work with polynomials. So let's see what we have to do. We have to set up a division. So I'm going to go my x plus 2 divided into 3x squared plus 2x minus 5. Okay? Now we got an x plus 2. We have 2 terms, right? But we're really going to divide just by the x. In fact, I'm going to circle the x. And this is what I divide by, okay? So, x, well, 5 went into 43, right? 5 went into 43, so x goes into 3x squared. Close. How about a 3x times? Now, if you don't see it, I say do a little bit of like mini division on the side. I'm going to do a little side work. Here's my side work so you can see it. Here's my side work. 3x squared divided by x is 3x. Yeah. Oh, I thought I gave you one.
I was in the bathroom.
Oh, yeah, okay, there you go. So so 3x squared divided by x, do a little side work. 3x squared divided by x is 3x. You guys agree with that? So I'm going to put down then my 3x, right? So let me find another color. Here we go. Yeah, that's not a very good color, but I'm going to go 3x. And what we did up here is we went the 8 times 5 or the 6 times 5. We'll do the same process. We're going to take my 3x times x, which makes a 3x squared. And I've got the 2. Now I need to use the 2 because I need to multiply the 3x times both of them. And the 3x times 2 makes a positive 6x.
Do we not have to write the positive 6 on top?
Help me out.
Like, are we not multiplying the 2 by the 3x squared also?
So I'm going to, just like we did here, 8 times 5, I'm going to take 3x times this. Just like the 8 times 5,
Oh.
Cassie, I'm taking the 3x times this, which is a 3x squared plus 6x, okay? Now, I'm subtracting, right? We have to be careful because we're subtracting them both, correct? So one of the things I do, just because I make mistakes, is I just push the negative through. So Brian, this is what I was showing. So what I do is I add a negative. See how I push the negative? So I push the negative through, I add a negative. So I just change the signs. It makes it easier for me not to make mistakes. Okay? So then 3x squared minus 3x squared is no x squared. That cancels, right? And then 2x squared minus 2x squared subtract 6x is a negative 4x. Okay? How am I doing? Well, let's bring down the next term. So bring down the next term, right? And then, just like I did up here, now I divide into the 30, right? Now I'm dividing into the 4x minus 5. All right. So x goes into negative 4x. How many times? Now, if you're not sure, we'll do a little side work, okay? A little side work. Okay, what is negative 4x divided by x, right? And it's easier to see, and then you know it's got to be a negative 4, correct? You agree with that because the x's cancel? So I'll have a negative 4. I'll put it as like a subtract 4, okay? Well, what I did up here with the 6, I multiplied the 6 times the 5, and I got 30, right? I'll do the same thing. I'll take my negative 4 times x and my negative 4 times the 2, right, Cassie? Times both of them, right? So negative 4 times x is a negative 4x, and a negative 4 times a positive 2 is a negative 8. Now I'm going to subtract, so I'm subtracting a negative. Everybody agree with that? So that I don't make mistakes, I know a negative makes a positive, negative makes a positive, so I just push the negative through and change the signs. That's all I'm doing, okay? So then, I'm going to,
Why do you want to change it positive?
because I'm subtracting a negative 8. Though I messed it up, I was going to subtract a negative 8, which is a plus, right? Brian, good question. Now do you see why I did it? This was a subtract a negative 8. I just make mistakes, Brian, so I'm just going to try not to.
Why don't we just keep them?
You can, and some kids can do that. So if you had this, let me put it up here, side work, right? You just have to be careful, right? You have to know that's a positive 4x, right? You have to know that's a positive 8. You agree with that? And I just did that so I wouldn't make the dumb mistake, because I do make dumb mistakes. Okay, now these cancel, right? And I get a positive 3. Now, x will not go into a 3. This is a bigger term than 3, so I'm done. This is my remainder. Does that make sense? It does not have an x, so I'm done. So this is my remainder. Remainder of 3. So my answer has to be, well, let's see. Up here, my answer was 86 and 1/5, right? 86 and 1/5. So my answer here is going to be 3x minus 4 plus 3 over x plus 2. Okay, I'll let you write that down and think about it, okay? So my answer is my 3x minus 4, but I have a remainder of 3. So it's 3 over what I divided by. It's 3 out of that, and so I just write as plus 3 over my divisor. Right? You've never done this before, I'm sure. Correct? So let's turn the page and do it again when you're ready. When you're ready, thumbs up. I'll wait for you, okay? Okay, it's hard, isn't it? Turn the page. Okay, so let's do it again. This time I have an x squared plus x into x cubed plus 4x squared. God, I love my job. 4x plus 5. Kids are singing in math class. How good can that be, huh? Yeah. So, all right, we're going to divide by the x squared, and then the x will come along when we multiply, okay? We're divided by the x squared, and we'll pick up the x we multiply. So, you ready? X cubed divided by x squared is what? It is x. And again, if you don't know that, you can do your side work, right? And you could try it. X cubed divided by x squared is equal to x. Okay, so x. And then we're going to multiply, right? We'll go this times this times this. I'll have a x cubed plus a 1x squared. It will. It will. You're ahead of me. You're ahead of me. Yes, it will. Good question. So then I'm going to subtract, right? I'm going to subtract, which will make it negative, right? So I'm going to subtract. But Brian, this is what I do. I don't have to do this. I just have to know I'm subtracting both. Because sometimes kids will forget that I'm subtracting this and they'll add it. Does that make sense? So I don't make mistakes, I just change the signs. Push through the negative, right? And then I tend to make less mistakes when I do that. And then cancels, and I get a 3x squared, right? Not a 5x squared, but a 3x squared. Okay. Bring down the next term, okay? Okay, and then I'll do the same process. X squared goes into 3x squared how many times? 3. And again, if you're not sure, you can do a little side work. So you can say, okay, side work, 3x squared divided by x squared. That's why I like my side work, because sometimes it's easier to see this way, right? It's definitely 3. And then, just like all division, long division, I need to multiply my 3 times my x squared and my 3 times my x, okay? So, we're going to get a 3x squared plus a 3x. I'm going to subtract, and as long as I'm careful, I don't need to change the signs. I need to know I'm going to subtract a 3x, right? But I make mistakes. I do, so I like to bring the negative through, so I add the negative. See what I'm saying? I'm adding the negative, which is the same thing as subtracting. I'm adding a negative, which is subtraction, right? So then I get a negative 7x. Bring down the next term. Now, x squared is bigger than 7x, higher degree, so it will not divide. So we have our answer. Our answer is going to be our x plus 3 plus my remainder. This is my remainder. So plus a negative 7x plus 5 over my x squared plus x. All right, it is a difficult day, all right? Yeah. I'm going to change this. I had 1 to 8 all, but I think I'll just change it to evens only. Yeah. So I'm on page 73. Let's go 2 through 8 even. That's only 4 problems, right? Okay, it will take some work. We have 10 minutes, so let's get started on it, okay, while I'm here to help. Come on. Come on.